Hello, Class A. This is me, Mr. Wee. So I'm going to go over 11-6 really quick. Not really quick, actually, but this is definitely going to be like a part one of the notes that we're going to kind of have to do together. So here's what I want you to draw. I want you to draw a table just like this. So if you want to pause it, you can. This is 11-6, secants, tangents, and angle measures. And then I want you to write sort of like at the top of your table here. And I want to do it kind of horizontally so you have enough room to write your notes. It's kind of like this is just like the labeling here, and then this here too as well. And then these squares we're gonna kind of put in, or we're gonna fill in. So there's gonna be quite a bit of content to kind of go through. So the first thing is basically I want to organize a little bit of what we got right now. So in your book you got a few things organized. Here are the main things I'm gonna try to hit. So I'm basically going to go over 11-2, and then I'm going to skip this middle section here, and here. I'm going to come back to that in part 2, and I'm going to go through these 3. So that's 4 total cases. If you think about it, it's 1, 2, 3, and then 4 right here, different theorems that we're going to put down in one table. I just think it's a little mishmashy. It's kind of weird. So here, what we're going to do is we're going to draw a circle, one circle in the interior. Here's what I mean by interior. We have a circle there, and we have 2 secants. We have 2 secant lines. We have 2 secant lines, 2 secants. So if you don't remember what that is, it's 2 lines, or it's a line that crosses the circle at 2 points. So let's draw 2 secant lines intersecting, okay? Oops, so let's see. That this intersect in the interior, anywhere in the interior. See here, it intersects in the interior of the angle, or of the circle, okay? So that's what 2 secant lines look like when they intersect in the interior of an angle. And let's label a few things. Let's say that this is angle 1, this is angle 2, okay? Angle 1 and 2. Let's say this is B, this is point C, so the end point that's touching on the circle is B, C. This end point is going to be A, and this end point is going to be D. Give me 1 second. I'm actually going to run away from my computer really quick to get another colored pen. So give me like 3 seconds. All right, I'm back. Okay, so here we are. We're going to say here, we're going to color code this in here. This is going to be kind of a purplish kind of hue. I don't think you can see this, so give me another second to find another different color. All right, I'm back again. Okay, so here and here, so if you guys can see that, basically what this says is if you want to find the measure of angle 1 for any case where you have two secant lines crossing on the interior, they intersect at the interior of a circle. How you're going to do that is you're going to have the measure of angle 1. It's going to be color coded. It's going to be equal to 1/2 times, basically, we'll give this a color code of 1, right? We're going to say that's 1/2 the measure of the arc AB, so it's A to B, plus the measure of the arc DC. Not too bad, huh? That's pretty cool. That's pretty easy. So it's basically saying if you want to find this angle measure, you just add these 2 arcs, the degrees of arcs, and then you just half them, and that's it. You get the measure of angle 1. So what's the difference between this and this, the exterior? Well, this scenario is going to be very similar, only we're going to have a circle again. We're going to have 2 secant lines. So let me draw this a little bit better. We're going to have 2 secant lines crossing in the circle. This was in the interior of the circle. What is this going to be? So let's go ahead and draw that and see if you can see the difference. It'll be almost the same exact thing, only it'll be a circle. Except they're going to cross at the exterior, meaning they're going to cross way out here. Here's a secant line that crosses the circle at 2 points. There, here, and here, it crosses that. That's one secant line, right? That's going to be B and D. And then let's say that another secant line that's going to cross on the outside. You see how it crosses out here? It's going to cross on the outside here. Boom, boom. See, it's meeting, not last time it was meeting on the inside. This time it's meeting on the exterior of the circle. So here it's going to be C and D, or C and E. And let's color code this. This is DE. And this, however, is BC. So, and then let's say that where they meet is A. They meet outside at A. What's funny, though, is now we're more curious about measure of angle A. We'll color code that, measure of angle A. This angle, basically. How big is this angle? If I was curious to know, it's simply this. The measure of angle A is 1/2. Last time, you took the measure of the interior angle, 1, okay? And what you did was you took the arcs, this arc and the opposite arc on the other side, you took them together, you add them, you half them. This one over here, what you're going to do is you're going to take, to find the measure of angle A, this angle A right here, this angle, you have to take the measure of angle of the bigger arc, okay, which is DE. So the bigger arc does have to come first, DE. And then you subtract it from the measure of the smaller arc, BC. Why is it that you subtract here, but you add here? The reason why is because you add them because they're occurring on the inside, the interior of the circle. This one here, because you're changing the dynamic, you're saying that these two secant lines are meeting on the outside of the angle, or on the outside of the circle, then you have to subtract them. The bigger one is the bigger minus the smaller arc, 1/2. See? And one more thing that I didn't want to add in to confuse you a little bit, but be aware that there is an angle 2 here. And what angle 2 is, if you wanted to find the measure of angle 2, you'd say it's 1/2 times, so opposite of this angle is the arc BC, the measure of angle BC, plus the opposite arc, which is right here, A to D. The measure of angle A to D. Okay, so you got 2 scenarios occurring here. You only really have one occurring here because you're only really curious about the arc or the angle on the outside now. Okay, so that leaves us with 2 other situations. Okay, so now we have one secant, one tangent. So what would that look like? There's a circle. I think I'm getting a little bit better with the circles. Yeah, yeah. Okay, so here is exterior. So that means we have a line that is secant, so we have one secant line and one tangent line, meaning there has to be a line that intersects this secant line on the outside, the exterior, but it has to be tangent to the line, meaning it can only touch this circle at 1 point, not 2 points. This is a secant line touching interacting through the circle at 2 points. This tangent line has to occur only at 1. So I know it looks like it's touching, but let's just say it's only touching at that point. And let me redraw that, actually. Yeah, I didn't do a great job there. Okay, and let's say it touches it at this point here. Right there. Okay. You can kind of see that it's meeting right about here. I kind of cheating by making this a huge point. But let's say that this is the tangent line, this is the secant line, okay? And let's shade in this minor arc, and then the bigger arc will be out here. Okay. And we'll say this is D at this endpoint here, and then this is C. Here will be B at this endpoint of the circle. And where they meet on the outside, I know it's really hard to see, but that's angle A, or that's A. So we wanted to find this small angle, like way in here. So we're talking way up in here, like way in here, like barely where I'm touching. That's angle A, okay? That's angle A. If I wanted to find, let's back up a second now. Let's back up to the big picture now. If I wanted to find the measure of angle A, what is that going to look like? I'll color code that. You might see there's a theme here. I'll color code that. The measure of angle A is simply the same thing as right here. They're actually not different. It's just different scenarios, but in any case, if you have two lines that are intersecting, either secant or tangent, intersecting on the outside, it's going to be the same formula. It's the measure of the bigger arc on the outside, measure of angle or arc DC, minus the smaller arc, BC. It's the same thing for even this guy, but I'll show you what that looks like. Okay, so it's the same formula. Anytime it's exterior, anytime that they're meeting on the outside of the circles, it's always going to be 1/2 of one arc minus the other arc, the bigger arc versus the smaller arc. And if it's interior, you simply just add them and then take the half. Okay, so here's the last example. Here's the measure. Oh, I'm getting worse in my circles. Not good. Okay, so let's make this a nice, big, juicy one. All right, that's the best I can do. Okay, there's a circle. Now let's meet a point out here. Let's say that that's A, and let's say I draw a tangent here, and I draw a tangent right about here. Remember, there's two lines that are tangent. Two lines that are tangent, okay? This is the third category, two tangent lines that are touching the circle at approximately 1 point. And, let's see, and their angle is on the outside here, right? And let's say it meets at B to, we'll even put a D here, and C, okay? So this giant arc here, notice I said B to D to C, because if I said arc BC, you don't know if I mean BC this way or BC that way. B to D to C. This D helps to say that this fat arc here, this big juicy arc out here, minus, okay, so I'm getting ahead of myself. So let's say if I wanted to find the measure of angle A. I'm going to oddly color code that. That's basically the measure of angle A is going to be equal to 1/2 times the arc, the measure of arc B to D to C. So the reason why this is important again is I want to say the bigger arc, B to D to C, is bigger than this, which is BC. If that D was not there, it would say arc of BC minus arc of BC. Wait, what do you mean? BC this way, or BC this way, or BC this way minus... I don't know. So again, there is a problem if I do this. If you communicated that, it wouldn't make quite sense to say arc of BC, and I know you mean this arc BC minus this arc BC, but I don't know that. A person that's reading that's like, wait, what does he mean? This bigger arc minus this bigger arc? That's just 0. No. So that's why it's really important. If you wanted to find which arc you're talking about, BC this way or BC this way, you just add another point in between the side that you want the arc to mean. So you want B, this side here. So I say B, and I'll put an additional point D and C. D does not occur on this part. So I know when you say arc BDC, I know you mean this arch, not this one. Okay. So arc BDC minus the smaller arc of BC. That's it. It's the same thing. So if you ever want to find the angles on the outside, this angle on the outside, exterior angles, you just take the bigger arc and subtract it from the small arc. That's it. On every scenario, either two secant lines crossing on the outside, two secant lines crossing on the, or one secant line and a tangent line crossing on the outside, or even two tangents on the outside. It's always the bigger arc minus the smaller arc and half that to get the exterior angle. Over here, again, it's different. If you're looking for the interior angles, you take the arc opposite of that and the arc opposite of that to add them and then half them. Okay, so let's go through some examples now. Okay, so actually I'm going to keep that. That's a really important note to have in the future. Okay, so let's go back to regular orientation now to reorient ourselves. So let's go through some examples. So let's say we got this example here. We have to find x. That's our main goal. And our first example is this circle. And we have two secant lines, technically, intersecting on the inside. Oh, clue. Two secants inside. Okay, interior. X degrees. And I have the arc here. This is T to U. And this is R to S. okay? And let's see, I want to find, and I know that what was given to me is TU is 130 degrees. I know it doesn't look like it. I didn't draw it very well, but TU is 130 degrees. R to S is 84 degrees. I want to find X. What do I do? I don't know. You could take a guess, or you could pause this and try this and unpause this and see what I get. But if you've already unpaused it, let me go through the answer now. Okay. So if you remember from our sheet here, if I have two intersecting secants on the inside, and I want to find one of the angles, I just find its arc opposite to that angle, and the arc kind of the mirror arc right behind it, and I add them, and then I half them. So if I want to find X, just find the arc that's opposite of it, which is 130 degrees, then the one right behind it, which is 84. So I'm going to say that the measure of, I don't know, let's say, what is this again? Let's see. Oh, sorry, this is V. This is V. So the measure of angle TVU, T to V to U, okay, or U to V to T, you could write that too as well, or the measure of angle U to V to T. Notice that V occurs in the middle of both of these. Well, anyways, I digress. It's the same thing. It doesn't matter what order you write it in. So you go to basically the arc, half of the arc of TU, the measure of angle TU, or the measure of, not angle, Mr. Wee, but the arc TU, okay, plus, it's on the interior, the arc behind it, which is arc of RS. Boom! And I know that is, let's just substitute that now. TU is 130 degrees plus RS, which is 84. If I do some quick math, I believe that's 214, yes? 214. And then if I took the half of that, that's basically 107 degrees. That is the measure of the angle UVT or TVU, or basically X degrees, which we were trying to look for. I don't know what X degrees was. I just found it. It's 107 degrees, okay? So that's using this one, the interior two secant lines crossing, right? Very good. Okay, let me give you another problem that you can try. This one's going to be a little trickier, okay? How about this guy? Boom, circle, two secants. You guys ready for this? You guys ready for this? Boom, whoa, where is it crossing? Okay, the interior again. All right, so it looks like Mr. Wee's not ready to move on, but let's say this is C, this is endpoint C, this is D, and this is 75 degrees, okay? And then this is B, this endpoint B right here. That's going to have an interior angle of X degrees. And let's say A up here, A to B, this huge arc is 143 degrees. Okay, so why don't you pause this and try to solve for X now? Whoa, this is a lot trickier. I don't know. There's a bunch of different ways you can try this. You can do this. So give it some time. I'm going to color code this to be purple. So there's, just letting you know, there's like two ways I can think of doing this, but go ahead and try it right now. Okay, so if you unpause the video, okay, if you paused it already and now you're unpausing it to see what I got, here's a solution that you can try, okay? The easy way that you're not taught, that I didn't just teach you, okay? You can try it this way, where you know that if you have a central angle, or let's say, let's see, give me 1 second here. 143. Okay, so what we can do here is maybe we could try to find this angle here, this weird dotted angle that I just created. So this measure of angle, I don't know what that is equal to, so I know it's kind of weird with the color coding. I shouldn't have done that. I'm so sorry. So let's try to make this black. Okay, so this is black. Let's focus on these guys, making it purple. These are purple now, okay? These are purple. These are super pink purplish, okay? So let's focus on these two. So I definitely apologize, okay? It's just basically 1/2 of these two added together, because it's crossing on the interior. 143 plus 75. That should give me, I think, 208 218 or 219, or is it? I think it's 218. Yes, 1/2 of 218. Okay. Why is this important, Mr. Wee? Well, I'll show you. So 109. So measure of angle, whatever that is, okay, is 109. This is 109. How does that help us for x degrees? Well, I know that this is a straight line. And any two angles or any angles that add up to the straight line should make 180 degrees. So I know that the measure of angle plus the measure of angle x, let's say x degrees, I don't know what that is 180 degrees. And I just figured out that this angle is 109 degrees. I just don't know what measure of angle x degrees is. I do know 180. And I just subtract 109 from both sides. And I should get, finally, that you have that measure of angle x degrees is, ta-da, 71 degrees. There you go. Okay, so again, another shining example of this interior angles, two secant lines crossing each other example. You might be asking yourself, well, Mr. Wee, I don't know where you're going with this because you haven't showed us anything with exterior angles. Well, I'm not going to. Not yet. Okay? Surprise, surprise. I have one more beautiful example of an interior angles problem, and then I'll go to some exterior angle problems, okay? So let's go through another one here. This is C, or am I numbering this A, B, and C, or 1, 2, and 3? Okay, good. A, B, C. Let's do another circle. Boom. Okay. Then I got two lines here and let's say here. Oh, it's a little. They're crossing on the interior now. All right. Okay. No biggie. No biggie. Okay. So let's say that this is G. This is H. This is J. They cross at L, and then over here is K. Let's see some other things that they give us. Let's color code this now, okay? So G to H, this is x degrees. Whoa, what if we need an arc that's x degrees? And whoopsie, let's see, this is 110 degrees. Let's flip it now. Let's say that the inside is already given to you, but the outside is not, but the other one though is, okay? The other guy is given to you. So this is 97 degrees. Let's try to find out x now. So let's first draw the notation out really quick for like the naming and so forth. So we know the measure of angle 2, okay, so remember this is measure of angle 2, is equal to, or was equal to, or still is equal to, half of the arc, measure of arc GH, almost drew an angle sign there, plus KJ. Oh, save myself again. Arc KJ. That's KJ. That's a very crazy KJ, okay? So let's go ahead and plug in the values that we got. I know that measure of angle 2 is already given to me, 110. Oh, all right. Then I got 1/2 times the measure of arc GH. I don't know what that measure of arc GH is, so I'm going to leave that as one giant variable. This whole thing is a giant variable, okay? Plus KJ, which is 97. I think I can solve that. As long as I got only one variable, I could totally solve for this. So let's go ahead and just do the distributive property. This is not going to be great. I'll be honest with you. I don't like the way this is going. Or, you know what you can do? Instead of doing that, that's a lot uglier. We know that's 110. Sorry about that. It's 1/2 times the measure of GH. It's nothing new, but instead, why don't we just try to get, instead of distributing that, because you know that that was not going to be easy, 97 divided by half, MGH divided by half, why don't we just multiply both sides by 2? Because I know that 2 times 1/2 will just cancel each other out and become 1. And then whatever I do to one side of the equal sign, I got to do the other. And this is going to be a lot cleaner. 220 is now equal to the measure of GH plus 97. Okay? And then I just subtract 97 from both sides. And then I should get about 123 is equal to the measure of GH now. There we go. So I just solved for this guy here. X degrees is 123. And that makes sense. I bet you, if you did 123 plus 97 and you divide it by 2, you should get 110. That's how you can check to see if your answer is correct. And I know I'm correct. Trust me. Okay, more examples. Wait a minute, Mr. Wee, I ain't finished. No, 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 no. You are not finished at all, good sir. We were dealing with all interior stuff. Okay, so now we're going to do some exterior work. What does that mean, Mr. Wee? So I'm going to say find each measure. A new set of problems now. And then here's the first one. So I'm going to give you a beautiful circle. Okay, as beautiful as I can draw it. Okay, we're going to give you a point L, and then we're going to do two tangent lines. Boom, and boom. Whoa! It's not tangent if it doesn't touch the circle, Mr. Wee. Come on. Okay, so that's still the meeting place, so that's a line that goes straight through. Only touches the circle at one point. And let's do this one. Let's try to attempt to touch this circle. There we are. That's a little bit better. Okay. On the exterior. So now they're not meeting on the interior. So we do not use the arcs adding to each other and then halving them. Okay. We are looking at this scenario. Okay. So you take a look at your notes. I just pulled my notes away from you. So let's say that this little arc right here is 102 degrees. Okay. And I want to solve for the measure of angle L. That's what I'm solving for. It's going to say, find each measure, find the measure of angle L. And it's just going to leave it like that. It's going to be blank, okay? So let's see. What else can we do here? All right, well, I want to find the measure of angle L. And come on, guys. So, oh, sorry. Well, let's first name the points here before I do anything. This is H and this is K. This is J. And then I'm going to color code this whole arc to be this color here. And I want to find L. So the measure of angle L will be equal to, so if you remember it, it's going to be 1/2 times the bigger arc. What is the bigger arc? Well, I know this whole circle creates an arc of 360, but this arc alone is 102. So if I wanted to, I would just do 360 minus, I'll color code it, 102. That should give me the measure of this arc, which I believe is a 268, or no, 258. So we're looking at this whole arc being 258 degrees. So just to reiterate, you got to be careful. Don't make this arc HK and then this arc HK. If you want this big giant arc, we have this additional point there for a purpose. We can say, if we say HJK, I know we're going to this giant arc because J doesn't occur down here. It only happens in this giant arc. So measure of HJK, that arc, minus the bigger arc minus the smaller arc minus the measure of arc HK, the smaller arc. That is the formula for the intersection of two tangents or any of these things here on the exterior. As long as they meet on the exterior of the circle here, you just take the giant arc, subtract it from the smaller arc, half that, okay? So the giant versus smaller, times that by 1/2, and then you should get the outside angle here. That's exactly what I'm doing. The outside angle here is L, so I'm going to take half of the big arc minus the small arc. So that should be 1/2 times 258 minus 102. Sorry, that should have been color coded to be 102. And let's say that is 1/2 times, what is that? I just gotta do it in my head. That I believe is 156. Am I right? Yeah, 156. Yeah. 156. If I take a half of 156, that should be 78 degrees. So the measure of angle L is 78 degrees. So in here, basically that is 78 degrees. Okay, very good. Let's go on to another problem. I think I'm just going to do one more. Mr. He's a little bit tired now. Okay, finally, he's tired, right? Measure of angle CD. Wait, Mr. Wee, wait, that's not even an angle. That's an arc. Okay, sorry. Find the measure of arc CD. Okay, let's draw a perfect circle, right? That's also a cool band too. Perfect circle, right? Let's do a point A out here. So that's definitely going to foreshadow where we're going to go. We're going to draw it to this point here, C. That's a tangent line, okay? Point C. And then let's say we're going to make a secant line. It's going to hit these 2 points, B and D. Boom. Boom. Okay, let's color code this. This is going to be D, and this is going to be C, and this is a giant arc out here. What we need to find is the measure of C to D. And look at what we have here. We don't have two tangents. I got one tangent line touching the circle at one point, but then I got a secant line. So what's our formula say here? Okay, in case you didn't get it the first time, it doesn't matter if it's two secants, one tangent, two tangents, as long as it meets exterior to the circle. You just take the outer bigger arc minus the smaller arc, take half of that. Basically, you take half of that, or you multiply it by 1/2, then you get the measure of the angle on the outside, the exterior angle. You do that for every scenario, including the one that we have right here. We're at one secant, one tangent. Exactly. One secant line is crossing one tangent line at the outside, on the outside. So measure of angle A, but interesting enough, we don't have CD. Oh, sorry, I didn't give you what's given, so let me give you what's given. Measure of angle A is already given to you as 56 degrees. This is already given to you. BC, however, is 95 degrees. The arc BC is 95 degrees. But let's just write out what we need. We know that the measure of the angle A is still going to be equal to 1/2 of the large arc, measure of arc DC, minus the measure of the arc, color code that, measure of the arc BC, all right? And let's substitute in some values. I know the measure of angle A is already 56 degrees, so you just substitute, really. We don't know what DC is. That's the question mark right there. We don't know what that is, so we're just going to leave that as DC. I don't know what that is. And we're going to subtract. Oh, this is already given to me. BC is already given to me as this arc, 95 degrees. And like I said, I don't want to do the distributive method to 1/2 of this and 1/2 of this. I'm just going to multiply this to 2, because I know that if I multiply this side by 2, the 1/2 goes away. That'll make it clean. Whatever I do to one side, I got to do to the other side. So it's going to be 112 is equal to the measure of DC minus 95 degrees. Sorry about that. 95 degrees. Let's add 95 to both sides. I should get 207 degrees is equal to the measure of DC. Very good. 207. Wait, did I do that right? Yeah, I believe so. Yeah, 207 degrees. Now, you might be asking, Mr. Wee, why didn't I just do like 90, or why didn't I just do like, the whole thing is 300, right? Why didn't I just do 300 minus 95? Well, be very careful, because that would mean this whole arc, and then like what you would basically be solving for is 360 minus 95 gives you this whole arc, B to D to C. This whole arc would be 360 minus 95. But I wasn't asking for this whole arc, was I? In fact, I'm leaving out BD. So you have no choice but to use this method to find out this is 207. In fact, if you think that 207 belonged to this whole arc, you'd be wrong, because 207 plus 95 is not 360. All right, guys, that's all I have for you guys today. I'm going to stop right here. You guys have a good day. Goodbye.